In a surprising turn of events, NASA's James Webb Space Telescope has made a discovery that has astronomers around the world in awe. A few weeks ago, the telescope discovered the earliest known galaxy in the universe. But now, it has detected something even more massive, a supermassive black hole moving away from its galaxy at an incredible speed of 4 million miles per hour. This latest discovery has very important implications and has generated much speculation among scientists and space enthusiasts about what it means for our understanding of the cosmos. The James Webb Space Telescope was launched on a mission to explore the first galaxies in the universe and has captured stunning images of the death of stars and galaxies from a few 100 million years after the Big Bang. We invite you to join us to explore the latest discoveries from this telescope. Remember to like and subscribe for more content like this one. The latest discovery is challenging the scientific community's current understanding of black holes. Black holes are generally thought of as huge entities that pull everything, including light, toward them. But the recently observed black hole appears to be having the opposite effect. Instead of absorbing light, it is creating new, young stars along a long trail. This new trail of newborn stars has been observed in the wake left behind by the black hole, which stretches an incredible 200,000 light-years. Scientists are puzzled by the unusual behavior of this black hole compared to others. A team led by Yale astronomy professor Peter B. recently reported their findings in the astrophysical journal Letters. NASA's Hubble Space Telescope also confirmed these observations, suggesting that the black hole awakens new stars when it comes into contact with gas and cools it behind the black hole. But that's not all. NASA has made an exciting announcement about the galactic merger ARP-220, which was captured by the James Webb Space Telescope. This impressive galactic merger can be seen shining among other galaxies in the night sky. When two spiral galaxies merge, the phenomenon known as ARP-220 shines brightest in the infrared, making it perfect for observation by the James Webb Space Telescope. It is classified as a luminous infrared galaxy, with an ultraviolet luminosity of 1 trillion suns, compared to our own galaxy, the Milky Way, which has a much lower luminosity of about 10 billion suns. ARP-220 is in the constellation of Serpens, about 250 million light-years away. It is considered the brightest of the 3 closest galactic collisions to Earth and is listed as the 220th object in the Atlas of Peculiar Galaxies. About 700 million years ago, 2 spiral galaxies collided in a huge explosion of star formation. This created a dense region approximately 5,000 light-years across, containing about 200 large star clusters. Surprisingly, this small area contains as much gas as the entire Milky Way. Previous observations with radio telescopes discovered about 100 supernova remnants in less than 500 light-years across. Then, the Hubble Space Telescope revealed that the parent galaxies are located 1,200 light-years apart, and that each core contains a rotating star formation ring that emits dazzling infrared light. The latest images captured by the James Webb Space Telescope show an impressive galactic merger of the two galaxies. This image also shows tiny tidal tails sticking out of the outskirts of the merger, indicating the gravitational pull between the two final galaxies. Red, cyan, and orange streams and filaments represent scattered organic materials in ARP-220. Another stunning discovery stumped scientists when researchers found primordial galaxies at the edge of the universe. They were skeptical about their authenticity. Some thought they might be nearby galaxies in disguise. So, they shared the data with other scientists around the world, hoping for the best. Amazingly, the James Webb Space Telescope confirmed that these ancient galaxies are real. Thanks to this revolutionary telescope, we can now observe the oldest galaxies ever seen. Astronomers estimate that light from these galaxies has traveled more than 13.5 billion years to reach Earth, giving us a glimpse into the distant past of the universe. These galaxies were discovered when the universe was young, shedding light on how quickly the first generations of galaxies emerged. The spectral data confirm that these galaxies are at the edge of our view, some even farther away than Hubble could see. The discovery is crucial because it validates one of the most important tasks of the James Webb Space Telescope, to study the early universe through light that has been traveling for more than 13.5 billion years. Its expertise in measuring extreme redshifts is what sets James Webb apart, allowing astronomers to peer into the infrared range and observe the first galaxies in the universe. The excitement in the air is palpable, as this discovery marks an important milestone in the exploration of the universe and in understanding its evolution. This discovery has had a major impact on our understanding of the cosmos. While scientists are still working to interpret the full significance of these observations, one thing is certain: the James Webb Space Telescope is rapidly transforming our knowledge of the universe. Every new image and data set it returns deepens our understanding of cosmic origins and the forces that shape the galaxies we see today. The implications of a supermassive black hole leaving its host galaxy, and leaving behind a trail of new stars, challenge long-held theories about how black holes behave. Traditionally, such entities are seen as stationary centers of gravity, anchored in place by the massive galaxies they inhabit. But this discovery suggests that under the right circumstances, even these cosmic giants can be ejected and roam the universe freely. Some scientists speculate that the black hole may have been flung out due to a gravitational interaction, possibly from the merger of multiple black holes or galaxies. These interactions, while rare, can produce powerful recoil forces capable of ejecting even a supermassive black hole at millions of miles per hour. This opens new lines of inquiry. How often do black holes escape their galaxies? Could there be more wandering black holes in the universe than we previously believed? And what does this mean for galaxy formation and star birth in the early universe? At the same time, discoveries like ARP-220 offer unprecedented insights into galactic evolution and starburst activity. Observing such luminous collisions in such detail allows scientists to study how galaxies grow through mergers, and how massive clouds of gas and dust collapse to form new generations of stars. Meanwhile, the conformation of primordial galaxies near the edge of the observable universe is perhaps the most poetic aspect of the telescope's achievements. These ancient light signatures, photons that have traveled for nearly the entire history of time, carry within them stories of the first structures that ever existed. They are silent witnesses to the infancy of the cosmos, long before Earth or our Sun were even conceived. Each new discovery by the James Webb Space Telescope is more than just a scientific finding. It's a reminder of how much we still don't know, and how vast and mysterious the universe truly is. With every image it sends back, we are taken a little further from our terrestrial perspective and a little closer to the great cosmic narrative that spans billions of years. Prompted by recent findings, NASA has begun developing even more powerful telescopes than the James Webb Space Telescope to confirm whether our understanding of the Big Bang is correct. Data obtained from Webb spectrometer and near-infrared camera have revealed that 4 of the 6 primordial galaxies exhibit extreme redshifts, indicating that Webb is observing them as they existed just 300 to 500 million years after the Big Bang, without the presence of bulky substances like carbon. This is surprising, considering the universe is estimated to be 13.8 billion years old. The existence of these galaxies suggests that we may need to revise our knowledge of the early universe. This has generated concern in the scientific community, as these new discoveries challenge the current cosmological inflation model and the Big Bang theory, both of which have unresolved issues, such as contradicting thermodynamic principles and lacking a clear explanation for what caused the Big Bang. In addition, the James Webb Space Telescope is discovering galaxies almost as old as the Big Bang itself, which questions everything we thought we knew about the origin of the universe. According to theoretical physicist Michio Kaku, the discovery of ancient galaxies found by the James Webb Space Telescope calls into question everything we once believed about the beginning of the universe. Previously, these galaxies were thought to be far less developed than the Milky Way. But new findings suggest we may be missing important information. The telescope has identified 6 galaxies that existed just 500 million years after the Big Bang and are up to 10 times greater in mass than the Milky Way. This raises the question, are our current theories about the creation of the universe correct? Kaku clarified that it took billions of years to build a galaxy like the Milky Way, so it's odd to find such massive, young, primordial galaxies. This discovery may require us to revise, and perhaps completely rewrite, the textbooks on the beginning of the universe. Findings from the James Webb Space Telescope challenge what we thought we knew about the Big Bang, leaving scientists at a crossroads. Despite this, NASA recently tweeted about a newly discovered galaxy cluster that dates to just 650 million years after the Big Bang, adding yet another intriguing piece to the cosmic puzzle. Astronomers have examined the data and concluded that this fledgling cluster is anticipated to expand in size and evolve into something similar to the colossal Coma A656 cluster. The location where all of this is happening is unique and special, situated in an area of accelerating galactic evolution. Thanks to the James Webb Space Telescope, researchers can now measure the velocities of these 7 galaxies, giving them the confidence to confirm that they are gravitationally bound together in a protocluster. To put this in perspective, NASA researchers compared these galaxies to small drops of water in different rivers that will eventually converge to form one large, powerful current. Clearly, what we previously believed about the Big Bang is being challenged. While the Big Bang likely did occur, what caused it remains a mystery. More data from the Webb telescope may soon provide evidence to either support or refute our existing theories. In any case, we must await further discoveries. The answer may be closer than we think. What are your thoughts on these discoveries? Share your thoughts in the comments box. I hope to see you again in the next video. Many thanks for watching. As researchers continue analyzing the data from the James Webb Space Telescope, the astronomical community finds itself at the threshold of a possible paradigm shift. For decades, the Big Bang theory has served as the prevailing model explaining the origin and early development of the universe. But these recent observations suggest that our timeline, and perhaps even our fundamental assumptions, may be incomplete or in need of revision. One of the most astonishing aspects of these findings is not just the age of the galaxies, but their structure and maturity. These galaxies are not the small, chaotic clusters scientists expected to find in the universe's infancy. Instead, they appear to be surprisingly massive and well-formed, hinting that galaxy formation may have occurred far more rapidly than previously believed. This accelerates the need to answer difficult questions. How could such large galaxies exist so soon after the Big Bang? Were the physical laws of the early universe different in some way? Is there an alternative explanation for redshift that we have yet to consider? Some physicists have begun proposing new models, modifications to the Big Bang theory, such as cyclic or bouncing universes, or even more exotic possibilities involving multiverse scenarios or unknown early universe forces. While these ideas are speculative, they are gaining attention in light of the puzzling data now in hand. At the same time, the importance of technological advancement cannot be overstated. The James Webb Space Telescope is opening a new window into the deep past of the cosmos. With its unmatched sensitivity and resolution, it is allowing scientists to peer farther and more clearly into the beginnings of time than ever before. But with every answer it provides, new questions emerge, questions that could define the next era of cosmology. The journey of discovery is far from over. As NASA and other global space agencies prepare the next generation of observational instruments, including even more sensitive telescopes and deep space missions, we stand on the edge of what could be one of the most revolutionary periods in modern science. Stay curious, stay informed, and keep questioning. The universe, it seems, is more mysterious and more magnificent than we ever imagined.